For the past few minutes, I've been taking time explaining and defining terms in simple harmonic motion, deriving formulas, and telling you that as displacement is equal to 0, velocity becomes maximum, while acceleration is equals maximum when displacement is equals amplitude. You may be wondering, all these explanations, how does it change the price of Gary in the market? How does it affect me? So if you have one or two confusions while I was explaining, or you really want to understand more, this session will make you understand. We are about to answer questions under simple harmonic motion. Hello, you are welcome to physics class with Flash Isaac. So far under motion, I've been able to cover linear motion, projectile motion, Newton's laws of motion, and motion in a circle. Remember, motion is the change in position of a body or of an object with time. How position changes with time. Under motion, I was able to establish that the cause of motion is force. Force is an agent that tends to change the position of a body. And remember, Newton's first law, which is referred to as the law of inertia, states that a body at rest will continue to be at rest. And if the body or object is already moving, it will continue to move in that uniform motion in a straight line unless it is acted upon by a force. So force is the agent that causes motion. And talking about force, force can be contact force or force field. Contact force requires contact between the bodies or the objects, while force field does not require contact. A good example of force field is the gravitational force. Every object that goes up will surely come down. This is as a result of gravity pulling all objects down. While explaining the types of motion, I explained rotational motion, I explained circular motion, and I explained that oscillatory motion is the to and fro motion of a body. For example, the motion of a punching bag. There is a bag here, you punch, this is the fixed point. So it moves to and fro about a fixed point. Simple harmonic motion can be defined as the motion of an object whose acceleration is proportional to the distance from a fixed point and is always directed towards that point. This motion takes place when the restoring force acting on the system is directly proportional to the displacement from its original point. If this is a body undergoing simple harmonic motion, at this point, we can say that this body is at rest. Let's call this a simple pendulum. When you displace this body, you push it, it swings to and fro. Remember, displacement is the point or where an object is over time. The difference between where an object started and where it is at a particular time. That is displacement. And displacement is different from distance. Distance is the ground an object covers over time. For example, if you are in state A, you move from state A to state B, let's say 20 meters. From state B to C, let's say here is 30 meters or kilometers. And to state D, 10 meters or kilometer. If you are to calculate your distance, it is simply 20 meters plus 30 meters plus 10 meters. This is the total ground you have covered. Meanwhile, displacement is the ground an object has covered from the starting point. So the displacement of this object is simply from here to here. That is your displacement. Where you started to where you are now. So it doesn't take account of all the ground you covered. Immediately you push this bus or this mass, as it swings, when it's going this way, there is a force bringing it back to the original position or the equilibrium position. This is what is referred to as restoring force. So it goes, the force pushes it back, it goes here again, the force pushes it back. So the restoring force is equals minus Ks, which means it is opposite to the displacement. Yes, that should be right. Because as you displaces the body, you pushes it, the restoring force should be opposite in order to bring the body back, This is why restoring force is the reason for simple harmonic motion. You may be asked, what is the reason for simple harmonic motion? It is simply restoring force. And why dealing with simple harmonic motion? Let's take a look at position time graph. Then we will see some terms used in simple harmonic motion. From here to this place, it has completed one full circle. So period is the time taken for a body to undergo a full circle in simple harmonic motion. That is period. What is full circle? If you have something like this, let's like this, you notice that from here to here is one period. It is the time the body takes to complete a full circle. At this point, the body has undergone the maximum displacement. You swing a body, the maximum position or the maximum displacement from the starting point is referred to as amplitude. So you can call here amplitude A. That is the maximum displacement from the starting point. And frequency is equal to 1 over period. As the period increases, the frequency reduces. So they have inverse relationship. While period is the time it takes a body to undergo a full circle in simple harmonic motion, frequency is the number of circles a body undergoes per second. So frequency is equal to 1 over period. So far, I've been able to explain period in simple harmonic motion, period T, and I said that period is 1 over frequency, just like frequency is 1 over period. While amplitude is the maximum displacement from the equilibrium position. Now, swinging of a pendulum bulb and mass attached to a spring are the top examples of bodies that undergo simple harmonic motion. Now, in the definition and explanation of simple harmonic motion, I have been talking about displacement. So what is the formula for displacement in simple harmonic motion? Displacement is simply S is equals A cos Wt plus alpha, or displacement is equals A cos theta, where theta is equals Wt plus alpha. W is angular velocity. We really dealt with this in motion in a circle, and T is time, while S is displacement, A is amplitude, which is the maximum displacement of a body from its equilibrium position. To get velocity from displacement, we simply differentiate. I was able to explain this in my calculus videos, differentiation especially. I will share a link to that in case you are interested. Now, given S is equals A cos Wt plus alpha, and remember, displacement is a function of time. Therefore, when you differentiate displacement with respect to time, to arrive at velocity. So velocity is equals A remains because it's a constant. When you differentiate cos Wt plus alpha, this is how it is done. Remember, go through my differentiation video. You will understand all those things. So A is out. You simply bring out, when you differentiate WT, you get W. Just like when you differentiate 2S, you get 2. Alpha is a constant. So differentiating the constant, you get 0. So we've differentiated the bracket and we got W. So when you differentiate cos, you get minus sine. So this is minus sine WT plus alpha. Rearranging, we have that velocity is equals minus A W sine WT plus alpha. And to get acceleration, we differentiate velocity. When you differentiate displacement, you get velocity. Remember, velocity is displacement over time. When you differentiate velocity, you get acceleration. This is because acceleration is the rate of change of velocity, or it is velocity over time. This gives you A is equals minus A, W is outside because they are not the topic of interest. Sine WT plus alpha. Differentiating this, when you differentiate sine, you get cos WT plus alpha. Like we did earlier, you differentiate the bracket to get W, so the W will come outside. Acceleration becomes A is equals minus A W times W, that is W squared cos WT plus alpha. So this is displacement, this is velocity, and this is acceleration. Now take a look at something else and a general formula you need to know. Now generally, velocity is equal to plus or minus the square root of A squared minus S squared, where A is amplitude and S is displacement. Similarly, acceleration is equals minus W square S, where, look at this, rearranging this acceleration, you have minus W square A cos WT plus alpha. Now compare this to this, or to this. They are the same, right? So therefore, A cos WT plus alpha is equals S, making acceleration equals minus W S, but W square S. There is something else. When displacement is equals 0, velocity is equals maximum. This is another popular question. What happens to velocity when displacement is equals 0 in simple harmonic motion? As displacement tends to 0, velocity becomes maximum. So if here is 0, V is equals W A, or W square root A square square root. Since here is 0, velocity is maximum, giving you W square root of A squared. And the square root of A squared is simply A. Therefore, V is equals WA. At displacement is equals 0, velocity is equals WA in simple harmonic motion. Look at acceleration. Acceleration is maximum when displacement is equals amplitude. If this happens, acceleration becomes maximum. How? If S is equals A, it means that acceleration is equals minus W square A. So in a simple harmonic motion question, if you are told that acceleration is equals, if you are told that displacement is equals amplitude, or if you are told that acceleration is maximum, you don't need to look for the displacement anymore. Simply use A in terms of displacement to find acceleration. The precautions to take in simple harmonic motion is that 1, the string is inextensible, and 2, the initial angle is small. You may also be asked, what are the factors that affect simple harmonic motion? The first one is obviously the size of the bulb in simple harmonic motion. Period is proportional to size of the bulb. For objects immersed in a fluid, example, a loaded test tube, the period is equals 2 pi root n rho Ga, where rho is density. While for simple pendulum, period is equals 2 pi root L over G. And for mass spring system, period is equals 2 pi root m over k. And remember, the factors affecting simple harmonic motion are size of the bulb, length, and acceleration due to gravity can affect simple harmonic motion. In simple harmonic motion, we have different types of oscillation. Remember, oscillation is the to and fro motion of a body. The first one is free oscillation. In free oscillation, the amplitude is constant. For forced oscillation, the amplitude reduces until it gets to 0. While for resonance, the bodies they move at the same natural frequency. Let's solve questions under simple harmonic motion. These questions require your attention. Calm down, relax, and remember steps from what we've explained earlier. Remember, physics requires principles, and it is following principles that makes you a principal. The first question says, what is the total energy in simple harmonic motion? Remember, energy is the ability or capacity to do work. The total energy in simple harmonic motion is simply the sum of the potential energy and the kinetic energy. In simple harmonic motion, we have potential energy and we have kinetic energy. So total energy, let's say total energy TE is equals potential energy plus kinetic energy. So this is the total energy of simple harmonic motion at any point. What is potential energy? Potential energy is simply the energy a body possesses due to position or due to height. For linear motions or we have that, let's for linear motions, potential energy is equals mgh, the mass times gravity times height. So where height can also be horizontal distance. Meanwhile, for simple harmonic motion, potential energy is half ks squared plus kinetic energy is the motion a body or object possesses due to motion. So the process of moving or motion in simple harmonic motion, kinetic energy is generated, and the formula for kinetic energy is 1 over 2 mv squared. Therefore, the total energy in simple harmonic motion is half ks squared plus half mv squared. Look at something else. As potential energy gets to maximum, kinetic energy becomes 0. As kinetic energy gets to maximum, potential energy becomes 0. So they have this inverse relationship. Question number 2 says, a spring balance of mass 0.4 kilogram is attached to the end of a spring while round a horizontal circle of radius 2 meters with a constant speed of 8 meters per second. Calculate the angular velocity. Angular velocity in simple harmonic motion or in circular motion or in motion in a circle is given by W, while V is linear velocity. From my video on motion in a circle, I derived that linear velocity V is equals WR, angular velocity times radius. In this case, we are told that mass M is equals 0.4 kg. We're also given the radius to be 2 meters. R is equals 2 meters. What else? At a constant speed of 8 meters per second. So V is equals 8 meters per second. So with this data given, we should be able to solve for the angular velocity, which is W is equals V over R, making W the subject formula. This becomes 8 meters per second over 2 meters. So this gives you 4 rads per second. Given that amplitude equals 2 centimeters, remember amplitude is the maximum displacement from the equilibrium position or from the mean position, and it says that the frequency equals 10 Hz. Hertz is the unit of frequency, so frequency is equals 10 Hz. Find period. T is equals question. This is a very simple question. Remember, I explained that frequency is equals 1 over period. Therefore, period is equals 1 over frequency. We are given frequency and asked to look for the period. It simply becomes period is equals 1 over 10 because frequency is equals 10 Hz. How do we divide this? 1 divided by 10, it will certainly give us 0 point something because 10 is bigger than 1. So put down 0 point. Then add imaginary 0 here to become 10. 10 divided by 10, 1. So 1. This is how 1 divided by 10 is 0.1. Let's see the next question. It says a particle of mass 0.25 kg. So mass M is equal to 0.25 kilogram. Vibrates with a period of 2.0 seconds. So period is equal to 2.0 seconds. If its greatest displacement is 0.4 meter, look at this. Greatest displacement. What did I tell you is greatest displacement? It is simply the amplitude. So amplitude is given to be 0.4 meter. Instead of them saying amplitude, they simply try to disguise it as greatest displacement. What else? What is its maximum kinetic energy? Kinetic energy, Ke, is equals question. So we are given period, we are given mass, we are given greatest displacement, amplitude, and we are asked to look for kinetic energy. What is kinetic energy? Kinetic energy is simply equals half mv squared. We have mass. We simply don't have v squared. So we need to look for velocity. Before then, remember that W is angular velocity, right? And V is linear velocity. V is equals WR. What else? W itself is equals 2 pi f. Take note of that. Angular velocity is equals 2 pi f. And what is f? F is frequency. And frequency is also 1 over period. This means angular velocity is equals 2 pi 1 over period, giving us 2 pi over t. W is equals 2 pi over t. In this case, we are given t to be 2. Therefore, W is equals 2 pi over 2 to give us pi. So, pi rads per second is simply the angular velocity. Recall that V is equals WR. So what is the radius? At maximum kinetic energy, it simply means that velocity is maximum. And recall from my explanation earlier, at maximum velocity, V is equals WA. You can take the video back, you will see where I explained and analyzed that. Meaning, at maximum displacement, V is equals WA. and V is equals W arrow. So arrow is equals A. If arrow is equals A, we've gotten what we want. A is 0.4, meaning arrow is equals 0.4. V is equals WA, which is equals pi rads per second times A or arrow, which is 0.4. This simply gives you 0.4 pi rads per second. How do we get kinetic energy? We simply substitute to have 1/2 times mass 0.25 kg times V squared, which is 0.4 pi squared. 0.25 times 0.16 times pi squared. Pi squared, you can take pi squared to be approximately 10 because it's 9.8 something. So 9.89 something something. So this is the same thing as 1/2 times 0.25 times 0.16 times, let's say, 10 squared. A body oscillates in simple harmonic motion according to the equation. So we are given S is equals 0.05 cos 3 pi t plus pi over 3. Displacement is equals A cos Wt plus alpha, right? If yes, by comparing if yes, by comparing, A is simply equals 0.05. So amplitude A is equals 0.05. That's the answer. And if you are to compare the other stuffs, W is equals Wt is equals 3 pi t. Dividing both sides by t, W is equals 3 pi. So this is the value for angular velocity, in case you are asked. Why alpha, which is the phase angle, also is pi over 3. We've related it and we've gotten the various parameters. And finally, a particle executing simple harmonic motion has frequency of 50 Hz. Frequency 50 Hz. F is equals 50 Hz. And amplitude A is equals 8.0 times 10⁻³ meters. Calculate the maximum velocity of its motion. V mass is equals question. Remember the formula I derived earlier. V is equals W A squared minus S squared. And I told you that at maximum velocity V mass, displacement is equals 0. Remember? So in that case, V mass is equals WA. We have amplitude. How do we get W? W is equals 2 pi f. This is equals 2 times 22/7 times 50. That is how we solve for W. This will give you 2.51 meters per second, if I am correct. So that is it for today on simple harmonic motion. I hope you found this class very, very helpful. I am Isaac. Don't forget to subscribe to this channel and feel free to check out my other videos. Thank you. Enjoy.